All right, today we are going to start looking at different functions, and we've been focusing on quadratic functions, and last year you focused on um, linear and exponential like we've talked about, and today we are going to start talking about different types of functions, and today we're going to focus solely on square root functions and talk about how they move, which is called shifts and transformations. And then we're going to talk about, again, like we did with quadratics, increasing and decreasing. So you're going to see a lot of the things that we did with quadratics come back up with these types of functions. So on your supplemental notes, it says graph the function, and that's a typo on our end. It shouldn't say from the video. Sorry, I guess technically this is a video, but you're just going to graph the function. So what I want you guys all to do is I want you to pick up your calculators, and I want you to go to y equals and type in the square root of x. So you're going to hit second, and then the square x squared button, if you look right above it, is the square root. And then x, close those parentheses, and then hit zoom standard, and you are going to see kind of what looks like half of a parabola. Excuse me. So I have given you a table of values. So if you go to your second table, go to your graph, go to second table. If you notice, we're used to seeing a lot of values in the column, the y column, which are nice and pretty, and these aren't anymore. And that's because we're dealing with a square root instead of a square like we have been. So here, when x is -2, if you notice it says error. And then when x is 0, it's 0. And when x is 1, it's 1. When x is 2, it's 1.414. Hold on, let's make sure you can actually read that. When x is 3, it's 1.73. And when x is 4, it's 2. So why are these numbers coming up the way it is? Well, if you look at the graph, notice nothing's happening. You have your y-axis down the middle. Nothing's happening on the left side. There's no graph at all. And if you go to your table, you're seeing all of these error. If you look at any negative value of x. Well, if you think about what we're graphing, and this kind of goes with what we talked about in Unit 1, we're graphing the square root of x. If I substitute in -2, that means I'm looking at the square root of -2. Well, if you remember, as soon as we had negatives, that came out of the radical as an I. Well, we're graphing on the real number system. This was the complex number system. So when you're dealing with square roots, you're never going to have any x values that make the whatever number it is, in this case it's just x, under the radical negative, because you can't graph those on the real number plane. So we are going to focus on graphing what we can. We have the point 0, 0. We have the point 1, 1. And then 2, 1.4, so you can kind of eyeball it. 3, 1.73, and then 4, 2. So your graph looks like that. So when we talk about domain and range here, domain, remember from last chapter, is all x values. Well, if you look in your table, all of the x values that are negative say error. So we can't include those in our domain. Our x values are going to start at 0. So my domain is going to start with a bracket at 0 because we're including 0, and it's going to go to infinity. As long as the number underneath the radical is positive, then we're okay, which is why it's 0 to infinity. Now, domain is all of our x values. So that means if you look at it this way, x goes left to right. So you go this way and you don't start any x values until here, and then 0 to infinity. Well, remember, range is your y value. So I'm going to do that same thing down here. I have no graph happening. There's literally no possible y value until I get to 0. And if you look at the table, your y values start at 0 and then they get bigger and bigger and bigger and bigger and bigger and bigger and bigger. So your range is actually the same thing. It's going to go from 0 to infinity. So remember, domain, like we talked about, is all your x's. range from last year is all of your possible y values. Okay. Now, increasing and decreasing hasn't changed. If you read like a book, left to right, you start at obviously 0, 0, because that's where your graph starts. Well, if you were to walk along that line, you're going uphill the whole time. So you're increasing starting at 0 to infinity. This is never going to stop increasing. You are never going to be decreasing here. Your numbers are never going to get smaller. So I would just put a line there. It's never going to be decreasing. Okay. So this is the graph of the square root of x, and this is what it looks like. What this is called is a parent function. So a parent function is a function where no transformations have occurred. That means we are not moving it up, down, left, right, etc. Because what we're going to start talking about today is what you see in your notes next. The general form of a radical function is f of x equals a times the nth root of x minus h plus k. So what I want you guys to do before we actually get into what that means is I want you to look at these 4 functions that we have at the bottom and take a few minutes and put them in your calculator. Now, notice when you put them in your calculator, this is the square root of x plus 2, not underneath the radical. Whereas the last one over here is the square root of x plus 2. The whole thing's under the radical. So be really careful how you put these in. And what I want you to do is just do the same table of values, okay, and get a feel for what each of these pictures look like. Okay, so what you should have gotten is this. Okay, so you should have 4 graphs that look like this. Mine are a little sloppier than what yours are. Hopefully yours look better than mine. But if you notice, I went in and in gray, I put the parent function, so when no transformations have occurred. So what that means, if you look, these are my final answers all in purple. Well, this graph from the gray to the purple moved up 2 units. This graph from the gray to the purple moved down 2 units. This graph of the square root of x minus 2 moved to the right 2 units. And this graph moved left 2 units. So if we go back up here, you have all these things happening on your general form of a radical function. If you notice these first 2, the plus 2 and the minus 2, when we added 2 on the outside, we moved up 2. When we subtracted 2, we moved down 2. So the k means we are going to have a vertical transformation. So it's either going to move up or it's going to move down. Now, what we want to notice is when we were dealing with the second 2, here we had x minus 2 and this was underneath the radical. Well, when you think minus, normally you would think either left or down, and this moved right. Here, when we had x plus 2, normally you would think up or right, and this moved left. So inside that h, which should look familiar, that h is actually a horizontal transformation. And when you have a horizontal transformation, you want to think opposite. Okay, because if you have x minus 2 underneath the radical, then it's going to go to the right. If you have x plus 2, it's going to go to the left. So the only thing, it's just like when we did vertex form and intercept form. If you're coming out of the parentheses, you're going to do the opposite of what it wants you to do. So that's something we're going to want to keep in mind. Now this A, we haven't talked about yet. We're going to come back to that in more detail later in the chapter, but it really means a vertical stretch or shrink. And we'll use our calculators for it now, and we'll talk about it more in detail in a few days. We're going to focus mainly on the vertical transformation and the horizontal transformation. Okay. Now, if you remember, everything in our notes from quadratics, everything was based off the vertex. You really want to know where the vertex was. That was a critical point of a parabola because everything was based off of that. For the square root, your critical point is going to be this point at 0, 0, and that's what we're going to move. So that is what we are going to refer to as the critical point. I think of it as the start of the graph. So when you hear the words critical point, that's what you want to think about, the actual start of the graph, which in our case is 0, 0. So we're going to flip this over and we're going to work through a couple of these and kind of what they actually look like. So on the back it says, describe how each function has been moved. Use the parent functions provided to help you. So this is all the stuff from the front page. So if you notice here, we have the square root of x minus 5. Well, this minus 5 is on the outside of the square root. So that means it's a vertical translation. So since it's minus 5, we have shifted down. I always rewrite it so I don't forget it when I go to graph it. 5 units. Okay. There's nothing inside the square root. It's just the square root of x. So we haven't had a shift left or right. Reflected. Well, remember, parabolas would flip upside down or, open up the other way if a was negative. We don't have a negative a value here. So there's no reflection and there's no number. Well, there's a 1, but there's not any number other than 1 in front, so there's no stretch. Okay. If you look at number 2, we have two things going on. We have a plus 3 on the outside of the radical, so that's a vertical movement. And then we have a minus 4 on the inside, so that's a horizontal movement. Okay. So when the questions are asked, has it been shifted left or right? Well, we do have a horizontal movement, and remember we want to do the opposite. So x minus 4 means instead of going to the left, what you really want to do is go to the right. So we're going to the right 4 units. And shifted up or down, we do have a vertical movement of that plus 3. So that's outside. So that's going to go with whatever it is. This is plus 3, so we go up 3 units. Now, then these two questions, I kind of touched on this in number 1, but these two questions come from the a value. Well, in this case, a is just 1. It's just 1 times that, so nothing's going to happen. No reflection, no stretch. Okay. If we look at number 3, we have 3 things going on. This minus 6 is on the outside and we're adding or subtracting, so this is vertical. Okay. This 2 is also on the outside, but we're multiplying 2 times the square root. So that's going to be my value of a, and that's going to affect these 2. And then I have an x plus 1 on the inside, so that's going to be horizontal. Okay, so we have a horizontal movement. This is plus 1. So horizontal, we do the opposite, just like the parentheses in intercept form and vertex form. So we're actually going to go to the left 1 unit. Shifted up or down, well, let's see. We have a plus 6. Sorry, my screen's not wanting to work with me here. Who's surprised? Oh, just kidding. We have a minus 6, so we're going down 6 units. Now, is it reflected? Well, a is positive, so no. And is it stretched? Yes, because a is something other than 1. So yes, it's stretched by a value of 2. Okay, so take a minute, and I want you to, actually that's a lie, I'm going to do this one with you, sorry. If you look on number 4, we have plus 5, so that's outside, so that's a vertical movement. And then here, this is outside, but we're multiplying, so this is our A value. A is -3. So has it shifted left or right? No. You can write no or a slash through it. Just don't leave it blank, because leaving it blank to me means you don't know. A slash means no or right no. There's nothing on the inside. It is just the square root of x. So we're not shifting left or right. This, we're moving up 5 units from our vertical shift. It is reflected because A is negative. And is it stretched? Yes. By a value of 3. Okay. So now what we're going to do is we're going to take 2 of those that we just did, and we're going to graph them and see what they actually look like. So I'm going to take a minute, and I'm going to put in my parent function so I can see what's really happening. Remember your parent function? I'm just going to do the easiest points. When I graph these, you guys, I don't do decimals. I focus on what are the whole numbers. So 0, 0, 1, 1, and 4, 2. And then if you were to keep going, there's 9, 3. I'm just going to throw it on there because I know it's there. But so that's our parent function from the front page. I'm going to do that on both of these so that once we graph our actual function that's been translated, we can see what happened to it. So we're going to graph number 1. All number 1 did was shift down 5 units. So we're going to go ahead, and I want you guys to go to your y equals, and I want you in y1 to type in the square root of x minus 5, and go ahead and make sure you're in Zoom Standard. And if you graph, you'll notice this graph, like it said, we should have moved down 5 units from our parent function, and it looks like we did. So let's check the table. Obviously, we can't pull any of our negative values because they all say error. So let's start at our first whole number, which is when x is 0. The next whole number for y is 1. I'm going to skip x is 2 because the y is a decimal. I'm going to skip when x is 3 because the y is decimal. When x is 4, we have a whole number, which is -3. Sorry, I'll fill all these in. When x was 0, we're at -5. When x is 1, we're at -4. And then the next whole number we have for the y's is at 9, which is -2. So I'm going to skip everything that's in between because it's all decimals and I'm not going to bother. So at 0, we're at -5. 1, 2, 3, 4, 5. Here we're at 1, -4. At 4, we're at -3. And at 9, we're at -2. Oops, sorry, I graphed that last one incorrectly. There we go, that's better. And then at 9, we're at -2. So your graph looks like that. So we took the gray graph, that's your parent function, the original, and every single point was moved down 5 units. So that's what your parent function looks like in gray, and then that's what the transform function looks like in red. Where is it increasing and where is it decreasing? Well, it's increasing. If we were to start at our critical point, which is now down here, and walk along that line, you're always going up. And if you were to look in your table, those y values are getting bigger and bigger and bigger and bigger and bigger and bigger and bigger. So we are increasing. Remember, we're only focusing on x values when we're doing increasing and decreasing. From 0 to infinity, and then we're never decreasing. Okay. So now I want you to take a minute, and I want you to put number 4 into your calculator. -3 times the square root of x, and then +5. Make sure that +5 is outside. And I want you to take a minute, and I want you to actually go through from your table. I want you to pull numbers that are whole y values and see what your picture looks like compared to your parent function. Okay, so what you should have gotten is those values for your x and y, and I graphed it in blue. Now, if you notice, we said there were a couple things going on here. We said there was no shift left or right, which is good because we started, our critical value hasn't shifted left or right. That's starting point. Okay, when I say critical point is right here, that's what I'm talking about, and it shifted from here to here. It shifted up 5 units. Well, it definitely went up 5 units, but then it said we reflected, which means instead of opening up here, these are kind of going up and to the right. Now we're going down. So that'll come into play with increasing and decreasing. And it's stretched by a value of 3. So if you look, this graph looks like somebody took it and pulled it down. So it's your rate of change is a little bit more steep in a way. So here with increasing and decreasing, well, if I were to walk along this line, I am not going uphill at all. I'm going downhill constantly. So I'm not increasing now because I had a reflection, and now I'm decreasing from 0 to infinity. Okay. All right. So now we're going to pick up our books. So if you open up your books to page 93, we're going to look through example number 1. And then we're going to look through the problem-based task. Okay. So on page 93, it says the function y equals 0.176 times the square root of x plus 30 has a domain of negative 30 is less than x is less than or equal to 0. Okay, so they're specifying where they want this at. It says determine the range of the function. So remember, those are our y values. And then use a graph to estimate the value of y when x equals negative 10. So it says determine the range of the function and domain. Well, the domain is given to us. Okay, so our domain is going from negative 30 to 0, and it's less than or equal to, less than or equal to, so we want to include those values. So our domain is going to be negative 30 to 0. And if you look at the graph that they set up for us, that's what they want us to have. Okay, now we could probably guess the range because they set this up for us. If you notice, it only goes up to a value of 1. So let's put this into our calculator. And we're going to have to adjust our table. So put this into your y1. Make sure the x plus 30 is all underneath, either all in parentheses or all underneath, depending on what kind of calculator you have. Okay. So we're going to change our window because it says our domain is negative 30 to 0. So my x min, I'm going to make negative 30, and my x max, I'm going to make 0. Because that's what they are specifying in this problem. It doesn't have any context, but it's just saying this is what we're going to look at. And then for our range, I'm going to use the values from the points on the graph. It says 0 to 1. So I'm going to make my y min 0, my y max 1. But you want to change your y scale here. Let's go by 0.1s just like the graph does. Otherwise, we won't see much. So now when you hit graph, you should see a good picture. And you can tell our range is going to be between 0 and 1. So let's hold off on writing what the actual range is. And it says find at least 3 points, including critical points. Well, if we think about this from a table perspective, just to make life easy, I want to know where this graph ends and where it starts and where it ends. So it's going to start at an x value of negative 30, and it's going to end, in this specific case, at an x value of 0. I'm going to hit negative 15. It's right in the middle, and it'll give me a good idea of what's going on. So I'm going to go to my table. When x is 0, I'm at 0.964. When x is negative 15, I'm at 0.682. And when x is negative 30, I'm at 0. So those are 3 points. Now this also answers our range question because our domain goes from negative 30 to 0. Well, when x is 30, we're at 0 for our y, so my range is going to start at 0. And then it's going to end when x is 0. Well, when x is 0, my range is, or my y value is 0.964. So my range is going to go from 0 to 0.964. Okay. So we have our points. We're going to graph them. We're at negative 30, 0. We're at negative 15. So this is going to be kind of in the middle, 0.62. I'm sorry, 0.682. So we're going to be kind of here-ish. And then at 0, we're at 0.964. So we're just above. So the specific graph goes from here to here. And then we stop. We don't have arrows because it's specifying it only wants from negative 30 to 0. It doesn't care what's happening beyond either side on the left or the right. So it says use the graph to estimate the function's output at the given input. They wanted us to know when x is 10. Well, I could probably, was it 10? Sorry, I already forgot. Negative 10. That makes way more sense. All right, so at negative 10, I'm here. I'm guessing I'm going to be somewhere around 0.8 if you look at the sketch of the graph. So let's look at our table. And when x is negative 10, we're hoping we're around something like 0.8, and we're at 0.7871. So when x is negative 10, y is a value of 0.7871. And that's pretty much spot on. I mean, this is a sketch, so it's not going to be perfect, but at negative 10, we're right there. Okay, so we did pretty good. All right. We will hold off on this, and I will do it with you when we come back. Okay, so now you're going to have time to work on your homework, at least until I come back and we do this problem together and make sure we're all on the same page.